Alright guys, here we are on page 2 of the review. So we start up here at number 11. Which of the following sets of segments can create a triangle? So again, make sure to read everything very carefully. This one asks, which one can create a triangle? Alright, it's not asking you what type of triangle it is, it's not asking you anything but can it make one? So there's no Pythagorean theorem or squaring here. This is A plus B has to be bigger than C. Okay, and you see that right there. So we tried each choice, and let's just add the first two, make them bigger, see if they're bigger than 3, not make them, but see what they are. So A, you see A plus B, 3 plus 5 is 8. 8 is not bigger than 8. That's a greater than sign that I crossed through because it's supposed to be bigger for it to work, but it's not. So remember, if they're equal, it's not, because that creates that situation where, you know, basically they just come back right on top of each other. It's a line on a line. You don't get your triangle. Choice B, 5 plus 8 is equal to 12. That's not 12. I can't believe I wrote that. Well, there's my first typo. That's 13. However, that is still bigger than 10, which is the important part. So yes, that should be our triangle. Just to check our work, though, on answer choice C, 6 plus 10 is 16, which is greater than 20. So that's good. 12. What angle classification would a triangle with side lengths of 5, 12, and 13 create? So now we are asking what type of triangle. Remember, the only reason we didn't include equiangular when we did this type of problem is because for it to be equiangular, it would make it equilateral, which means all three numbers would be the same. So obviously 5, 12, and 13 different numbers. So you take a squared plus b squared, which you see right there. You have 25 and 144, which is 169. You do c squared, which is a 13. 13 squared is also 169. When they're equal, that is a right triangle, because that is literally the Pythagorean theorem. You see here on the bottom, for those of you trying to remember, if a squared plus b squared is bigger, that's acute. If c squared is bigger, it's obtuse. All right, so just to remember those rules. 13, angle QRS is 94. Find the measure of QRT. So QRT, the whole big thing, is 94. The smaller angle to the bottom is 34. The big one's 94, the smaller one's 34, and you're looking for the one that's missing. Remember basically that these two angles, you know, if I label them, that's kind of hard to see. 1 and 2, they combine to make the big angle, right? It's a simple idea, but, you know, they combine. So adding them together should give you 94, which you see over here. And then you really just subtract the 34 from 94. You get 60, and that's what the x equals, that angle 1 that's labeled there. Pretty simple. 14s are lines. Our lines M and N parallel justify our answer. So this is technically the converse of the parallel lines and transversals. If I'm trying to prove that they're parallel, I have to show that one of those angle relationships exists and that they are true, right? Like here you have these two angles marked. Sorry. Here and here. Okay, that's saying that those two angles are congruent. So the first question is, what is the relationship of those two angles? What would you call them? Right? And they would be called alternate exterior. All the alternates, exterior and interior, are supposed to be equal to each other. But you can only have that if the lines were parallel. So if you actually show that alternate exterior angles are congruent, then that means the lines are parallel. That's why you see yes, because alternate exterior angles are congruent. Is triangle WZY congruent to triangle WXY? Justify your answer. So just a quick reminder, there are 5 triangle shortcuts for congruence: SSS, SAS, ASA, AAS, and then HO, which is hypotenuse leg. Here you see there is 1, 2 sides, and then they share the middle. That's 3 sides marked congruent. No other angles, or none of the angles in the picture are mentioned as being congruent or given any kind of indication of what they are. So, clearly it's SSS, which is the true one, correct one there. 14, which 2 postulates or theorems do not show the triangle congruence? And that would be AA and SSA, right? These 2 you can show them, but you wouldn't mean the 2 triangles you have are congruent, right? AAA. Well, I think I have the pen selected, and then I move it, and so it anytime I've explained something and the screen shakes. That's why. Sorry about that. But yeah, AAA and then SSA, which of course backwards is your butt. It's hilarious. Haha. 17, in the figure below, what is the value of x plus y? This is a example of utilizing exterior angle and vertical angles in the middle there. So x and y, you'll notice, are both located as an exterior angle. There's x, there's y. Their value should equal the sum of the 2 remote interior angles. That's the 2 angles it's not next to. Simple reason being is that the third angle, which is missing here and here, has to make 180 with both the exterior angle, because that's a linear pair. Like here at x, that's a linear pair. Here at y, that's a linear pair. Plus, we all know triangles add up to 180. So putting those 2 ideas together, they both have to make that angle equal to 180, therefore they equal each other. So that's the simple part of it. X is 80 plus 40, which is 120. Y is 40 plus 70, which is 110. If you realize that, you take them, add them together, and get 230. 18, if G is the centroid of V. What happened to this copy? That's odd. It should be triangle ABC, not weird V ABC. AD is 30, CG is 15, and AD is perpendicular to CB. Honestly, the main parts of the information that you need to know are the vocab centroid and what a centroid is and what it does. Centroid is a point of concurrency for medians, meaning in this picture here, AD, EC, and BF are all medians. They go from an angle to the middle of the opposite side. So in theory, F, E, and D are midpoints, although that doesn't really play into how we get our answer. What's key here is when you connect 3 medians and a meet at a centroid, they cut each median into a 2/3 to 1/3 segments, basically, which you see we wrote here. So, for instance, in the one we care about from A to D, A to G is 2/3 of the length, G to D is 1/3. Excuse me. So all you really need to do is find out what is 2/3 of 30. That means multiply, you get 20. 19, in the digraph, DM is a midsegment of the given triangle. Find the length of BC. Midsegment is half the length of the third side of the triangle. And most importantly, or maybe not most importantly, but a midsegment is where you connect midpoints inside a triangle. So if you just make one midsegment, it connects 2 sides, and it should be parallel to a third side. So the parallel part, not as important. What is as important is that it is half of the third side. So the length of DF is half of BC. We know DF is 12 because it shows us right there. So half of what is 12? That would be 24. Find the value of x. So here's another example similar to the problems up there. This is an exterior angle. 120 is exterior. The theorem again says it should equal the remote interior angle sum, or the two angles it's not next to added up together. So 3x plus 72 equals 120, and then you can see the algebra right there. Subtract the 72, divide by 3, you get 16 for x. All right, that's video number 2, or page number 2. There'll be a third page. Hope these are helping. If you're watching them, good luck on your tests.